In this video, we're going to look at solving some one-step equations. Now, some important things to remember is that when we're dealing with an equal sign, that basically the equal sign is telling me that I have a balanced equation. The left side of the equation must be the exact same as the right-hand side. And that's important for when it comes time for me to start moving things. And most of the times you're trying to rewrite an equation for some variable in order to see what it equals or is equivalent to. If I have a problem like x plus or minus a number, now c and d are just numbers here. In order to move addition, I have to do the opposite operation to get it to the other side, which means that I would need to, because c is adding, I would need to subtract it from both sides, so that way I just have x all by itself. Now, likewise, if I was subtracting c, in order to get the minus c away from the x, I'm going to add it to both sides. So to undo subtraction, you got to do the opposite operation. I got to add it. So if I add c to both sides, it'd make this c cancel out. Leave me with just x on the left, and I'd have d plus c left on the right-hand side to put together. Now, if I had a number times x and I wanted to get x all by itself, to undo a number times x, you're basically going to divide both sides by that number. And so since I had c times x, I'm going to turn around, I'm going to divide both sides by c. In doing so, c divided by itself makes 1, so I am left with just x on the left and whatever d divided by c is on the right. And lastly, to undo x being divided by a number, I would need to undo division, which means I'm going to multiply both sides by c. And so if I were to take the x over c and times it by c itself, that's going to cancel out that division right here and leave me with just x. And then c times d is just going to be c times d, or whatever the product is of those two values. So we'll work here and we'll get an example of each scenario. So first problem I have here is x plus 5 equals 3, and I want x to be all by itself. Now something you can do to help remind you that you have a balanced equation, I can draw a line right here up under the equal sign. And to move the 5, because it's adding, I have to minus it from both sides. And in doing so, that's going to cancel this 5 out. And I'm left with x. Then I have my equal sign. And then 3 minus 5, it gives me negative 2. Done. Next problem, I have x minus 7 equals negative 8. And I want to have x all by itself. So I'm going to draw my line right here up under the equal sign. I want to move the minus 7. Well, in order to move the minus 7, I got to do the opposite operation. I'm going to add 7 to both sides. That's going to take the minus 7 off the left, leave me with just x. So I have x equals, I got to remember to drop that equal sign down, and negative 8 plus 7, negative 1. Next example, 3x equals negative 21. Now I want to rewrite it as x equals whatever's on the other side. I'm going to draw a line here up underneath my equal sign. To take that 3 off, the 3 is currently multiplying to the x, so I'd have to divide it off the x to leave me with x all by itself. Well, because I divided the left by 3, I have to divide the right hand by 3. You can act like that line I'm drawing up underneath the x is a mirror. So both sides of the mirror have to have the same thing. And so the left side would have just x, and then negative 21 divided by 3 makes negative 7. So now I have x divided by 5 is equal to negative 4, and I wanted it just to be x on the left-hand side. Well, x is currently being divided by 5. To undo division, you have to multiply. So to remove the divide by 5, I times the left by 5, I times the right by 5. That's going to make these 5's cancel out, which is going to leave me with just x on the left equals negative 4 times 5 makes negative 20. Last example here has to deal with if I just have a negative sign in front of the variable I'm solving for and how to get rid of it. Well, to undo a negative sign, think of this as a -1. So I really have -1 times x. And to follow what we did before, to take off the number that's multiplying to the x, I could just divide both sides by that number. And so -1 divided by itself, that's going to take that off and leave me with just x. And 10 divided by -1 gives me -10. So let's talk about the absolute value function and what it means. The absolute value function tells you the distance a number is from 0. Now, distance is a non-negative value. It always has to be 0 or greater. Now, when we think about our number system has positive numbers and negative numbers, and it has 0. Well, the absolute value basically ignores what direction you're going. It doesn't care if you're going in the negative direction or the positive direction. It just says, hey, how far away are you from 0? Now, what that means is I'm just trying to compare, all right, no matter what I'm looking at, how many units away from 0 are you? So, looking at the first example, that's what the two vertical lines mean. So the absolute value of +3. Well, how far away is +3 from 0? 3 units. So the absolute value of +3 is +3. Well, what about the absolute value of -3? Well, -3 is also 3 units away from 0. So the absolute value of -3 turns into +3. What about 0? Well, the absolute value of 0. Well, the absolute value sign is telling me how far away a unit is or a number is from 0. Well, 0 is at 0, which means the absolute value of 0 is itself, 0. So a way to think about the absolute value function is it turns all negatives into positives, and all positives will stay the same. Now let's talk about how we would solve some one-step equations involving the absolute value. Now, if I'm looking at this first problem here, the absolute value of x is equal to 5. And I want to solve for x. Now, there is something important to note before you even start these kinds of problems. And the thing that's important to note is that the smallest number that the absolute value can output, and I have that right up here, the smallest number that the absolute value can output is 0. So all values that come out of the absolute value have to be 0 or bigger. So if I ever see a problem where I'm telling you the absolute value is like a negative number, I can't do that, and I'd have no solution. So back to this problem we were doing. The absolute value of x equals 5. So what you're going to do is you have to think, well, first, this number is not negative, so I can do this problem. And second, what two numbers has the absolute value of 5? Well, we just did an example with 3 and -3. So when solving, I'm going to take my problem, I'm going to set the inside equal to +5, and I'm going to take what's inside of the absolute value, and I'm also going to set it equal to -5, because the absolute value of both 5 and -5 is +5. Now let's look at this next one, which is what I was hinting at a little bit earlier, is that if I have the absolute value of some kind of expression involving x, some unknown, and I'm telling you that that's going to equal a negative number. Well, absolute value by definition tells me the distance a value is from 0, which means it has to, that my absolute value has to equal number 0 or bigger. Well, -2 is smaller than 0, so I can't do this problem. And what I would write is no solution.